This is Kids First C tutorial number 9, a complete guide from Nothing to Basic Understanding of C by Victor Wong. This is the last one. This is a review. Let's see. Overview. In this lesson, we will review all of the contents discussed in all of the other slideshows. So this will be more like a review, and also we will have some problems for you to solve. For a review of the basic parts of a program, you should recognize this picture. This picture was the same picture used in the lesson 1. And it gives you a good demo of the stdio.h, which allows you to put out printf functions. And also it's a good example of the main function, int main. And that's a function, and we'll cover that in that slideshow too. But for now, for int main, you can also think of it as just the thing that runs your program too. Here is the review for basic syntax. Semicolons are to C programming as periods is to English. It's the ending for statements, so the computer knows that you ended the statement. Identifiers are the name for variables, functions, and other things. Identifiers have certain rules because if they were anything, that would be some trouble. They can only start with a letter or underscore, so they cannot be started with a digit, and can be followed with letters, numbers, and underscores. The underscore is kind of like a replacement for spaces. So if you wanted to have a space in your variable, replace it with an underscore. Reserved words are words that cannot be used, as the name implies, because otherwise the computer would get confused. These are like data types, important pre-built-in functions, or like if statements, things that are automatically defined already. So you can't define them as a variable because then the computer would get confused. Then you have white space. White space is pretty basic. The name tells you what it is. It's space that's white. It's a tab, a space, or a line. Most commonly when people say add a white space, they most likely mean either add tabs or spaces. But sometimes they'll say add a bunch of empty lines. White space is required on some things like variable declaration because you can't smush together an int and your identifier, but other times it's used to make code cleaner. For example, for addition, you could exclude the spaces, but it's much recommended to use spaces because it makes it a lot easier to read. Data types. Data types are what type of variable a variable is. Not the variable itself, but what type of variable. For example, if you're having food, the name of the food is the data type, and the food physically, like the stuff you can eat, is the variable. That's a metaphor, because you can't eat a word, obviously. Similar thing here. The data type, you cannot assign values, you cannot change them. No, it's just a type of variable that you can use. There's an int, long, char, and there's a lot more. There can also be there's also decimal types that you can use if you have decimal numbers. Keep in mind that for a float, if you have an integer put into a float, it will have a 0.0 at the end. Unsigned data types expand the positive range to almost twice the original range, but the negative range is no more. It's from 0 to almost double the positive range of whatever unsigned data type you chose. So if you want to use negative numbers, do not use unsigned data types. Defining variables. So variables are defined with the data type we talked about, an identifier talked about in the basic syntax, and a semicolon we also talked about in basic syntax. Now variables, they can be very useful because you can assign numbers to them and then use them later, and you can change them, and you can use them in math calculations, you can use them in relational calculations, you can use them in all sorts of things. And variables, as the name implies, can change and most likely will be changed, or otherwise they're kind of useless. You can also chain them, so if you need a lot of variables with the same data type, you can chain them so you don't have to write like 10 ints. If you are using int variables and you have 10 variables, you can just chain them using a comma and one semicolon at the end. Operators. Operators are not functions and do not need any arguments or parentheses, but they're just basic things that allow you to do certain things like math calculations logical things, comparing numbers, and a lot more stuff. Now keep in mind that operators sound like they're only math calculations, but they can be used for all sorts of other things. However, you need to keep in mind as the order of execution does matter here. There is one, and therefore you might get unexpected results if you didn't consider them. Luckily, you can use parentheses like you would just expect. Here's a short list of some of the operators. Plus, minus, times, divide, those are kind of very basic. Equal is a check to see if both of them are equal. Bigger or equal to see if one number is bigger or equal to the other number. Also, a bigger only variant exists. A smaller equal and a smaller variance both exist too. The AND, which is used for getting addresses of variables located inside a computer. Plus equal. So plus equal might get you confused sometimes. But basically, if you want to add a number to another variable itself, so for example, c plus 7, instead of saying c plus 7 equals c, which would be kind of confusing if you had a lot of those, you can just use c plus equals 7, and it will just add 7 to the c variable directly. It's more like a shortcut. Also, minus equal is another variant that is the exact same, except that it minuses number, not adds numbers. Decision making. Decision making is very important, as you can guess, because a lot of C programming has to do with if a situation or just an example. So there are statements including an if, an else, a switch, and an else if. If should feel pretty basic. If sounds exactly what it does. If something is qualifying another thing, then do something inside brackets. Elsewhere, there's an else, so if it does not qualify, then it can go into the else where it does something else. And there's an else if you want to chain if and else if. So in this example, we have num1 equals 10. So assume it doesn't equal 10. Then it passes the if. Then there's an else if. So then if num1 equals num2, those two variables. Now let's assume that they don't. Then else, that code is executed instead. The switch is like a way you can chain a bunch of else ifs, except that you don't actually have to write else ifs. You can use cases. And cases can be for this situation, if num1 equals 0, do something. Now, the thing is that it's a good idea to put a default, which is if num1 doesn't satisfy any of those cases, you can chain lots of them together, and you have to use colons between each case. Also, depending on your usage, you might want to put a break, because otherwise, if, for example, you have case 0 to 5, if case 0 is satisfied, but it also satisfies case 1 and case 2, for example, then it would do all of them, which is sometimes not what you want. So it's a good idea, if you need it, put a break. Loops. So suppose you want to run some code, but you don't want to run it like 100 times. Yes, there is a way to avert that, and those are loops. While loops repeat code until a condition is false. As you can see in the first example, while num1 equals 5. So as long as num1 equals 5, the code inside will be repeatedly run until num1 doesn't equal 5. Now quick note, whiles sometimes won't run at all. If num1 equals 5 is not true in the first place, it will just skip the while loop entirely in all of its code. Which means that sometimes if you want to run at least one time, you can use a do while, which you add a do and put the while condition check at the bottom. However, those aren't very commonly used, and you most likely don't want to use them. For loops are also very common too. They have a variable, a condition, and an increment. And the variable is kind of like your control thing. It controls it, and there's conditions that can vary, and you can even put other variables in the conditions. Then you have an increment. If you didn't have an increment, the only way you could stop your for loop would be either it doesn't work in the first place, like the while situation, or the condition uses another variable, and that variable changed or you literally just want an infinite loop. Infinite loops are also kind of useful, but quick note is that infinite loops cannot be unless you use breaks. You're going to have to use Control C when it's running, or otherwise it will run forever. And infinite loops can be used while things can be true. For while you can make them while true, which is always true, so it'll always do it forever. Or for a for, you can just invert everything and just put semicolons. Quick note, for the for loop, all of the stuff, the variable, condition, and increment can all be gotten rid of, and that creates the infinite loop too. But maybe you don't want a condition, or maybe you already declare a variable and you only put int, or maybe you just already declare a variable and you assigned it, so you can invert the first thing entirely. Functions. Functions are very important if you want code to be repeated sometimes, but you don't want it to be repeated all the time. Because for a while, if you want the code to be repeated for some time, then don't repeat and run. Sometimes you will have to use multiple whiles. And sometimes functions are convenient if you want to call in all sorts of places throughout your code, not just in one big place. Which means that functions are how you do that. They can be declared, called, and defined. Declared is the same as definition, except that you just don't put the body of the function code. And you can and that says the computer's okay, it's somewhere else in the code. And then you can define it later on, including at the bottom of your code, outside of the main function. Now, functions are defined with a function return type, which is what it's going to return. If you do not want to return nothing, if you want to return nothing, then put void. The name, it's an identifier, just like variables, and optional arguments. Optional because sometimes you don't need arguments, but arguments are variables that in the initial condition, when your function is called, will be sent to your function. So maybe if you want to do a multiplication function, then your arguments could be num1 and num2, and then you could say num1 times num2. Now, quick note, the argument's name does not have to be the same as the actual variables that were sent into the arguments as the argument. But the thing is that it's a good idea to make them the same name, otherwise you'll get confused. Calling a function, because otherwise if you wrote a big function but it doesn't do anything, most likely you didn't call it. So in order to call a function, you need to use the name or the identifier, and you need to use that argument if there were any. If there were not, then just put 2 parentheses. If there were, put the arguments in and use a comma to separate each of them. 2 problems. These are problems to see if you actually listen of the tutorial to see what you learned. Now use an if statement to compare 2 numbers. And the second one is to use a loop. Any loop doesn't have to be specifically a while or a for to print out all the numbers from 200 to 20,000. Yikes, that's a lot of numbers. I don't want to manually use a printf for all of those. Use a function to compare numbers. Quick note, if you use a function to compare numbers and use an if inside that function, then you can satisfy both the first one and the third one. And assign a variable to be a day. For example, Saturday equals 6, Sunday equals 0, Monday equals 1, Tuesday equals 2, so on and so on. And use a switch to print it out. And all solutions can be found on GitHub. The challenge problem is to make a game that lets the computer generate a random number. Asks users to input a number to guess, so you can guess number, say 50, and the computer will say if it's bigger or smaller until the number you guess is the same as the computer made up. You will need scanf to allow user input. Hint, the game has only one way to end, which is that you win and you got the correct number, and there's no losing. Maybe you say, well, losing is that if you took more than 10 turns. Maybe, but in the bear game, there's no losing. Again, the solution is found at GitHub. Conclusion. It's time to finally wrap up this tutorial. In this tutorial, you hopefully have learned all the basic things for C programming. Now, there are a bunch more things that you can learn, but this is just a basic one. So if you want to learn more things, you can check out a bunch of our tutorials. But until then, bye-bye, and see you next time!